Assalamualaikum warahmatullahi wabarakatuh. My name is Teguh Fashami Raza. I'm from UIN Aranya University. Today I will review about the improvement of facial recognition by artificial neural networks using principal component analysis, written by Shadha Baker, Hasham Hashim Muhammad, Hanan Al-Dabak. Abstract features are extracted using principal component analysis (PCA) to reduce the dimensionality of the face image. Four models were created. The first one was trained using feed-forward backpropagation learning with 40 features. The second was trained using 50 features with FFBBL. The third and fourth models were trained using the same features but using element neural network. FFBBL gave accuracy of which features respectively, while element gives for which features respectively. 1. Introduction. The technique of pattern recognition is one of the most successful techniques in the field of image processing. The new spaces are often feature space. This helps to reduce the calculation of the image database in a controlled way to obtain higher recognition and best accuracy. The basic face database is defined as all training patterns of the same size and configuration. In this work, we utilize facial recognition from the ORL database. Neural networks give high efficiency in computational technique to pattern recognition and image processing, which led to their widely use in this field. 2. Related words. The researchers introduced reliable and automated systems that depend on async algorithm for the face recognition, and it's applied on students' face. The system proposed using both principal component analysis as well as histogram of oriented gradient for feature extraction and artificial neural network for recognition, coupled with help feature machine. The researchers in present a face recognition system in which principal component analysis and backpropagation neural networks in performance were used for face identification and verification, while the implement face recognition system is done by using neural network. Its acceptance ratio was greater than 90% for the proposed matching methods. 3. Research method. Some particular methodologies need to be followed in order to implement the proposed algorithm dealing with the face recognition system. For this process, certain steps need to be taken. The proposed algorithm includes major steps are as follows, shown in Figure 1. A. Pre-processing. In these steps, the face detection process checks if the image is a face image or not. The face cropping only from the entire image using the Viola-Jones algorithm. Transfer the image of the face cropped to size 50 times 60, as shown in Figure 2. B. Finding the eigendata matrix to be used in subsequent steps to extract feature. Figure 3 represents the flowchart for the finding of the eigenmatrix. C. extracting the features of the faces using the eigenvectors of the face calculated by step 2. Figure 4 represents the flowchart of the extraction features process. D. Training and testing of two artificial neural networks. One of them is of type FFBBL and the other is element neural network. A. Backpropagation network. BBN has proved successful in identifying and recognition patterns. It is a kind of supervised learning network. The basis of its work depends on the gradual regression method used to update the weight values to find the lowest mean square error between the output values of the network and the target values. The training of the backpropagation network goes through two phases. Feed-forward stage. The input from the input layer moves to the hidden layer according to their number, ending with the output layer, and then comparing the actual output values with the desired output values to calculate the difference between them, which represents the error value. Next, feedback phase. At this stage, the weights of the grid are adjusted depending on the error value. This process continues until the true output value becomes as close as possible to the desired output value. B. Element network. The element network is a special kind of backpropagation networks. It has been used in the fields of recognition and classification to contain a dynamic memory that can be used to retrieve the hidden layer to the input layer, thus speeding up the network. The element network consists of the input and output layers in addition to the hidden layer. Using the backpropagation frequency of the error, the weights are adjusted and the network is given the ability to recognition patterns through different iterative phases, and figure 6 illustrates the architecture of element network. Each set of features are used to train two types of artificial networks with forward-back propagation learning and element network. These networks was training using the Levenberg-Marquardt backpropagation algorithm for backpropagation learning. 4. Research and analysis. Artificial neural network of feed-forward backpropagation learning. A. FFBBL training with 40 features. The input layer in this network has 40 nodes and the output layer has 10 nodes. Figure 7a illustrates the topology of this network. The training process took 35 minutes, 33 seconds, and the neural network reached stability after 21 epochs. This network accuracy is 98.33%. Network performance was measured using MSE and it's illustrated in Figure B. B. FFBBL trained with 50 features. In the input layer, 50 nodes of this neural network and output layer 10 nodes. Figure 8a illustrates the topology of this network. The training process took 24 minutes and 55 seconds to reach a state of stability after 30 epochs. This network recognizes face with 98.80% accuracy. Network performance was measured using MSE and it's illustrated in figure 8b. Next, element artificial neural network. A. The network training on 40 features. In the input layer, 40 nodes of this neural network and output layer 10 nodes. The topology of this network is shown in figure 9a. The training process took 35 minutes and 33 seconds to reach of states of stability after 41 epochs. This network recognized the face by 98.33% correctly. Figure 9b shows the MSE performance curve. B. Network training on 50 properties. The input layer has 50 nodes and 10 nodes in the output layer. Figure 10a illustrates the topology of this network. The training process took 41 minutes 44 seconds and reached stability after 25 epochs. This network recognized face with 95.14% accuracy. And figure 10b shows the MSE curve. The accuracy of face recognition of the proposed method is very high. FFBBL has 98.33, 98.80 accuracy, while element has 98.33, 95.14 accuracy for 40, 50 features, respectively. The Table 1 summarizes the four modules and their related results information. 5. Conclusion. Face recognition is among the most common applications in many areas which can be used as a replacement to the password of the identification of criminals. In this work, a proposed method for face recognition by NN using PCA was presented. We can infer from the result that there is an inverse relation between both the number of features extracted and the number of epochs. That is, when the features increase, the epoch number decreases. In either case, the recognition accuracy is high. In FFBBL with 50 features, the recognition accuracy is high comparing with element with the same number of features. Also, the training time increased from 24:55 to 41:44. That's how I confirm the video and there are mistakes. I apologize and thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.